Let's get started. Welcome everybody to 52 Living Ideas. Today we are going to be talking about the ideas of Russell Ackoff. Now, it's going to be about systems and learning and comprehensivism. Uh, I don't know much about him. I've read his, I've watched the video 2, 3 times. I watched a few other videos. I read some of his writing, just a little bit. But it's, even at this level, firstly, the ideas are very deep and they speak to me in the sense that I hold them too in different form. I think he holds it in a far more essentialized form than I do, but they speak to me very directly. So I'm very excited about it. Now, the way I want to do this is I want to do it in a far more engaged way. So the pattern is going to be that I'm going to be talking about two topics. One is about systems thinking, his ideas about systems thinking. I'm using only the video and the basic ideas from the video. Then we're going to have breakout rooms so all of us can talk about the ideas about the systems thinking approach to solving problem and how is it different than approach that most people use. After which we're going to come back and then I'm going to talk about his concept of learning and teaching, which is quite revolutionary. And then we're going to have breakout rooms, far more focused breakout rooms on that concept. And then we'll come back and share our takeaways. So I'm going to, my presentation is going to be fairly simple, fairly brief. So first thing, I want to know how many of you have either watched the video or read the blog post that I had, which does a decent job of summarizing his thought. So I know where to pitch it. You can either go to the participants panel and click on yes or no, or you can put it in chat. You can say yes or no. Even if you've watched a part of it and you think that you have some sense of what he's saying, you can say yes. So we got what? Wow. Okay, we got 10 plus. Okay, so good number of maybe half the people have read it. Okay, that's fine. So what I'm going to do is I'm going to actually present very briefly his core ideas. And then we're going to have, I'll take some questions and then we'll have discussion. So this is going to be a highly interactive way of talking about Ackoff's ideas, okay? So let me get started. So the first idea is systems thinking. So what is system? What is a system? And the core part here is to see that it's the basic idea is that you look at the whole. You focus on the whole system, not the part. You always start with the whole. You always say, okay, what is the larger context of which this is a part? And make sure that you have the whole before you drill down into parts. Because system as a whole has properties which cannot be explained by just a catalog of its parts, because the parts interact with each other to produce the system behavior. The system behavior is what you're trying to grasp. So it is essentially focused on the whole. And then whenever you're looking at a part, you see how the part is operating in the whole by interacting with all its subparts. He gives great examples of a car. Car is something which can take you, whose function is that it can take you from one place to another. But when you look at any individual part of it, let's say it's motor, if you separate it out from the rest, it just sits there. It cannot even provide the propulsion. It cannot move by itself. And just understanding each of the parts thoroughly is not going to be able to, is not going to enable you to put the car together. So it's all about focus on the whole first and looking at the parts only in the context of the whole. Um, I'm going to jump to the end of the video now, where he talks about, he says, reality is a system of problems. So there are no, even, he says, even a problem doesn't happen in isolation. It's an artificial construct. And if you really want to solve a problem, you have to see the system of problems within which it is a part. Because if you identify a problem using, methods that people do, he says some of them are exercises, some of them are questions. But even when you say that, okay, this is a problem, many times the way you specify the problem, you are leaving out some crucial, relevant elements of the problem. So it is, so what he's saying is that you look at reality as a system of problems, and then you navigate that system. He says, again, I like his metaphor of Humpty Dumpty. It's like a Humpty Dumpty. When Humpty Dumpty falls off a wall, and when it breaks, you break that problem into multiple things. You cannot put it together. You cannot put these isolated pieces together. So you have to start with the whole. He says there are four ways of approaching a problem. One is that you can absolve yourself, or you can evade the problem, that there is a problem, which is what many people do, unfortunately, for many problems. The second one he calls resolution. That means you use your system one, your automatic, your memory, your habits, whatever your culture is, and try to find something that satisfies, that kind of achieves satisficing. That means that somehow it kind of deals with the problem. It's not necessarily a perfect solution. You're basically just dipping into your past. You're dipping into your memory. You're dipping into kind of ready-made solutions, and you're just trying to put it together. So that's second kind of problem solving. The third kind of problem solving is what he calls problem solving, which is, he says you're trying to resolve the problem. You're trying to solve the problem by finding optimal solutions. So you're trying to analyze the problem. You're trying to quantify the problem as opposed to qualitative. So for the second kind that we talked about, it's mostly kind of a qualitative process. This third kind, it is more experimental, it is more quantitative, and you're trying to solve the problem that way. So that's the third kind. But he says there is a fourth kind, which is really the most powerful, which what he calls is dissolving the problem. He says you redesign the space around the problem so that the problem doesn't exist anymore. Okay, and that's what the art of design is all about. So again, in the system thinking, design is a very large concept. I'm doing this series on Buckminster Fuller, and the next book that CJ has recommended to me, it's CJ is priceless. He's been an amazing guide for me. I've been this is very common for me. I get excited about a thinker or a field, and I dive dive into it, try to learn everything I can. The advantage I have this time is twofold. One is I have these meetups. So I'm presenting whatever I know to people, and people are giving me all kinds of comments and questions and points of view, which enables me to correct my mistakes, to clarify my thoughts, to see connections which I've not seen before. So that's one of the resource, which is speeding things up. And second resource is CJ, because he really knows, I've spent 3 weeks studying Bucky. He spent 3 decades. So that's a factor of 500 times. And at the same time, he is not a person who gets enamored by terminology. and becomes kind of completely wedded to it. He's able to look at another person and say, what of these ideas will actually speak to this person? So the next thing that he has recommended for me is a book called Design Strategy by Buckminster Fuller. Again, it's the core idea of design. So I think that there is some gold there. We are just barely able to touch that in this presentation, but I look forward to discussing this in greater amount of detail. Um, Even Ackoff points out that for architects, he also trained as an architect, just like Bucky, and just like one of my favorite people, that is Louis Sullivan. So all three of them are architects, and when you're an architect, the idea of trying to solve the whole problem is very natural, and that's what so there is a lot to be learned by saying, okay, you're trying to architect a system, you're trying to design a system. So that's a very different way than either ignoring the problem or trying to solve it with something that is readily available in your memory or around you, or third, trying to solve it through very careful quantification. Now, like, quantification, of course, is a part of the design, but it is subservient to the idea of design, that you're trying to solve the problem by looking at the context outside. So that's the third point I wanted to make. Now, the fourth point I want to make is that of the idea of Akov of disciplines. So what Akov is saying is actually quite earth-shattering in today's context. But this is something that, for example, this series of Comprehensivist Wednesdays is all about. What he's saying is that there are no disciplines as separate silos. See, people think that a problem is a physics problem, or a chemistry problem, or a social problem, or a psychology problem. But this is all connected. And what Ackoff is saying is that a discipline is simply a view, a perspective on a problem. And the more familiar you are with more such perspectives, the better your ability to solve the problems is. So instead of saying that this is a physics problem and I'm trying to solve it with physics, or this is an education problem I'm solving with ideas on education, you're trying to say, okay, you're saying that this is a problem. What is it? And you use all the tools, you master all the tools. So it's kind of transdisciplinary. He says it's not disciplinary, it is not multidisciplinary, it is not cross-disciplinary, but it is transdisciplinary. You move through, you go across any discipline that you need in order to solve the problem. So that's a core idea of Ackoff. The last general point I'll make, and then I will give a couple of examples, is that very often changes in a field, radical changes in the field, come from outside the field. He gives examples. I love his style of speaking. He gives these numerous examples. The first example he gives on this is that for a celebration of 100-year anniversary or something like that, the Association for Statistician asked their members who has contributed most fundamentally to the field of statistics. And they did multiple rounds, and they finally chose 4 finalists who would be addressing them at their conference. And none of those 4 had ever taken a course in statistics. Okay, this is not unusual. Okay, you have to be the child who says that emperor has no clothes. You have to be the person who sees connections that people have not seen. What people tend to do is that people tend to just reuse the tools that have been developed and not look at the problem afresh. Um, Now, I want to give you the best example that he talks about of systems thinking, and then I'm going to open it up to questions. So he talks about this case where there is there is a school district, and something like 80 to 90% of the high school kids cannot read, are functionally illiterate, and they have tried every possible method, reading method of solving. So they just got all experts in reading, they got many experts on teaching, and they tried to teach these kids and they failed again and again. um, and they finally called him and say, can you help? So he says, I don't know anything about this field. And the people tell him that we've talked to everybody in this field and none of them have been able to do anything. So try. So he said, sure. And then he actually goes and talks to these kids and tries to find out why. Why is it that they are not reading? Because first thing he notices is that these kids are very bright. They're extremely bright. There's nothing wrong with them. At the same time, they're not reading. And he finds out that 65% of um, their homes don't have a single book. Their parents don't read. Um, the neighborhood is such that by age of 12, you have to become a part of a gang and move around with your friends so that you don't get killed. Um, it's a very rough neighborhood. And all of, the gangs would beat you up if you're carrying a book, because that was considered as kowtowing to the white culture. And so there was no incentive, and it was whatever culture that they had was oral culture, as while people spoke to each other. And so there was no use. So when you have this young woman, white woman, telling that, oh, reading is critical for your future, that did not really mean anything to them. They saw it as being complete BS. Okay. Now, when I heard of this, I said, wow, that's an amazing problem. It's like my reaction was, wow, I don't know that this is solvable. Um, and then he proceeds in the video to tell what he did and how he solved it. To my astonishment, what they did was that they started playing Charlie Chaplin's silent movies on giant screen in the cafeteria. Now, Charlie Chaplin is a genius, so those movies are incredible, um, and they have subtitles. And they made a rule in the school that any child that wants to leave their classroom, they can go to the cafeteria anytime they wanted without any reason. And they found that kids flocked there, and within a few months, 90% of the kids were reading because they wanted to read those subtitles. They already had all the tools. It was all there. They just had no motivation to do that. So this is a classic example of looking at a system to solve a problem. Okay, so that's what systems thinking is about, and this is part of the series that I'm doing. This is the third video on third meetup and YouTube video on systems that we are doing here. The first one was Buckminster Fuller's approach to systems. The second was an interview with Tom Gilb, who's here, on systems engineering. And this is the third one. And we're going to continue looking at Bucky's approach to systems through his book. And hopefully at some point, I'm going to take up that design strategy book of Bucky. But I want to see how, I want to now actually engage in the dialogue here to see what people think about this. So what we'll start with is we'll start with some questions. Please keep the questions. So we have 4 rules. To ask a question, type exclamation mark in chat or raise your hand in Zoom. Number 2, keep on topic. We're talking about systems thinking today. Number 3, be brief. And number 4, speak your mind, disagree with anything on anything with anybody, and do so courteously. All right. So with that, Joe is first. Joe, go ahead.
Hi, Shrikant. Thank you for presenting this evening. One of the things that really stuck out to me was the saying by Peter Drucker, when he quoted Peter Drucker by saying that we are more interested in doing the wrong thing right instead of doing the right thing wrong. And, that really just resonated with me. But one of the interesting things is that really important to that process in knowing what wrong and right is setting up a boundary. And in systems thinking, I found that to be very difficult sometimes. And I'm just, in the sense that where is the boundary, stop? And I thought about it even in terms of practical terms, like if you're working at Amazon, what's the boundary? You have so many different areas that you're involved in. How do you define what the boundary really is? And that has always been a problem for me within systems thinking, because you really can just let your mind go and it becomes a diminishing return. So I was wondering if you had any thoughts on that particular topic, or if anybody in the audience may even want to opine,
Sure.
basically the idea of setting up boundaries and the idea of the pursuit of efficiency within that, right? And that's another aspect of this. The pursuit of efficiency actually ends up being inefficient. That's because of the boundaries are set up incorrectly. So, yeah.
Beautiful.
So,
Excellent. So what I'm going to do is that first, let's do a round where people put all their, at this point, if you have watched the video, if you're familiar, or if you read something, feel free to comment on what you got from it, what you got from the video. Okay, well, let's put everything on the table and then we'll do a full-fledged discussion. So I like both the points. I think these are great points. And one is the point of effectiveness versus efficiency, of kind of getting the what right versus getting the how right. That getting the what right comes first. If you don't have that, then no matter what you do with how doesn't really help you. Um, and so that hierarchy. And second is the issue of boundaries. So we'll keep coming back to these. So let's put everything on the table. Next up is Dave. Dave, go ahead.
I bet you want me to unmute myself. Yeah, to me, the main point I got out of it, and to me, it was fascinating. As I said, I have a little ways to go, but he is, to me, like Bucky, but not afraid to look at the problem in a different perspective, like having kids teach to learn, that you don't learn by having somebody teach you. And like your example of the kids that weren't able to read, instead of just hiring another teacher, it's a whole nother way of looking at the solution, that we get so stuck in the status quo. And that's my bug in education, that we have to take the summers off, because 100 years ago, we all lived on the farm and had to go home and help dad with the farm. And so we have all these stupid things, but well, we've always done it that way. So that to me is a big problem in industry and everything in our society. Thank you.
Excellent. Thank you. I want to again recommend Louis Sullivan also on this. He formulated the principle of form follows function. I have done 2 or 3 meetups on Louis Sullivan. This also goes to the heart of it, and I did that with. I cheated there. I had additional, what shall I say, reinforcements in the shape of my friend Sherry Trasinski, who is an architect who knows Louis Sullivan very well. So it's all, I think it's same thing about, form follows function. What happens is that there is a function, there's a real thing that you're trying to do, and you come up with a solution for that. And then afterwards, people just keep on mindlessly using the same solution without going back to the function of what is it that you're trying to accomplish with it. So excellent point, Dave. Sanjay, you had an answer to the question on boundaries. Go ahead.
Sure. I mean, I've been involved in systems thinking and system design for quite some time. So, I mean, there's no right or wrong answer to what constitutes the boundary of the system that you're trying to work with. And this is a little bit of the art part of engineering and architecture, in that as you gain ability, as you gain experience in this, you'll get better at defining the boundary. But basically, the best way I can suggest is to define the, well, first the example that Joe, you gave, as far as all of Amazon, is too broad. Now, you can start with that, but the boundary that you have may be either too complex, or it might be, I mean, for example, one example you can take with Amazon is to draw the boundary around every operation that the corporation Amazon is involved in, and draw a boundary around that. So activities that people from within Amazon perform versus people from activities from non-Amazon personnel perform, right? That can be one type of boundary for Amazon, but that would be too large and it would not really help you. First define the specific area of Amazon that you want to look at. Let's say the distribution system, right? Because that's a fairly important one for them. And even that's large. And then you might want to think about exactly what about the distribution system are you trying to assess. It might not be a problem. It might be that you're trying to improve it. Start with how you want to draw the boundary for their distribution system, right? The distribution system would consist of, for example, the U.S. Postal Service, international postal carriers, express mail carriers, and maybe even their own carrier system, as well as the IT infrastructure that they use for distribution, as well as they may use, outsourced staff, whatever you're aware of about Amazon's distribution operation. Create the boundary that you think is accurate, and then try to solve the problem using that. And then go through an iteration where then you tweak the boundary that you started with and try to solve it again and see if that gives you better. And that'll give you an understanding of what constitutes a good definition of boundary. There's no right or wrong. It does come from experience, in my opinion.
Thank you, Sanjay. Next up is Ryan and Anita. Ryan, go ahead.
Yeah, on the topic of efficiency, I unfortunately didn't get the chance to listen to the more than 10 minutes or so of the YouTube video, so apologies for that. But one thing that does leave me a little troubled about systems is that, in my perspective, I'm a new student in systems engineering. The goal of solving a problem is either the establishment or the improvement of a system, broadly. However, the longevity of a system naturally leads to inefficiency. So I think that's something that's a little bit perplexing to me about systems and design and systems thinking in general, that I'd love to hear comments from the rest on.
Right. I'm very new to systems thinking, so I do not know how to express that in that terminology, but I'm familiar with Louis Sullivan's approach to thinking about it. And he thinks about it in terms of function and form. See, what happens is that there is a function that you're trying to solve. And in order to solve that, you come up with a form. Form is the specific structure which is implementing that function. Now we are living in we are living beings, and we are living in a living world. So things keep changing all the time. The functions keep transforming all the time. And you have to keep on adjusting the structures to meet the requirements as they develop. Not only that, you keep discovering more things as you design. And so that back and forth of being aware. So it's so design process is a feedback loop. It's a relentless feedback loop. So what you're describing, that you're going to have to kind of fix the system, that's a feature, not a bug. You have to kind of continuously keep on updating the form to match the function, because the function itself is transforming and your understanding of the function is transforming. So that's how I would say. Now, Arvind, did you have a question?
Yes, if you don't mind. I have first an observation. I knew Russ Ackoff. I took my PhD in operations research under Ackoff, at Case Institute from 1958 to 61. So if I just make one or two observations about him
Please
personally.
take your time. I would love to hear whatever you have to say. Please take at least 5 minutes.
Well, Russ was clearly very brilliant. He had more ideas per hour than any person I've ever met in my life. And I've met some pretty smart people. However, he was a very poor judge of his own ideas. What he needed was someone to walk behind him. And as the ideas flowed out, the person would take a look and say, no, that's no good. There's a gem right there. I'll keep that one. So that was really a characteristic of him. He was a very poor judge of his own ideas. But again, very brilliant, and his best ideas were superb. Let me make an observation on systems too, and it's related to the boundary issue. Really, the system consists of components and subsystems. So if you took the car example, the engine is not a part, it's a subsystem, which has its own inputs and outputs and criteria and functions to perform. And the car itself is embedded in a larger system. So we really have a hierarchy of systems here, okay? And some components which have no function except be a component. But the boundary issue really is related to at what level of system you're going to deal with. And you can cut off at any level. I can be concerned with just the engine of a car and look only at its inputs and its outputs, for example, consider it a black box and judge it totally as a system all by itself, okay? Just as we judge the car as a system all by itself. So really you can cut off the system at any point. Each one is until we're finally embedded in the universe, which is the largest system. So the boundary issue is really this question of what system are we talking about and where we're willing to cut off the consideration. And in considering the car, for example, it's certainly legitimate to consider the subsystems of the car. I can optimize or improve the engine as long as it's a black box and has the same outputs and the kind of inputs. I can improve its efficiency and improve the system as a whole by doing so, even though I don't change anything else in the system. So it's certainly possible to deal with these systems at any level. And I think that's part of the boundary issue is at what level do you want to consider the system?
Arvind, may I ask you a couple of questions
Sure.
about Ackoff's work? Okay. The approach that I have and we have in these meetups is a syntopical approach. So whenever we take up a topic, we take kind of great thinkers, many different great thinkers on the topic. So currently we are looking at Buckminster Fuller, we are looking at Ackoff, we are looking at Louis Sullivan, we have Tom Gilb. So we're trying to put it all together. Now, so a couple of questions. What do you think the contributions of Ackoff are to the field of systems thinking? Where does he fit in? And are there other giants in this field that we should be looking at?
Okay. I can't say that I'm thoroughly read on systems thinking generally. I know Ackoff in particular, and I know some of his thinking. And I've read a little bit about some of the others, but I certainly don't consider myself anything like an authority. And Ackoff certainly is a brilliant man. I mean, he was a brilliant man, and he had some great ideas. He was also, frankly, very self-aggrandizing. And in addition, I don't trust all the stories that he tells. Mm-hmm. Because I was in a meeting once where he was describing a project I was working on. And at the end, I said, oh, was I doing that? I didn't know that, you know? that his description of what I was doing was so far beyond what I was actually doing that I hardly recognized it. Mm-hmm, mm-hmm. But you've got to be careful in any of these things to take with a grain of salt, that the stories may be great illustrations, but not be completely true. I mean, that's also part of it. But the systems thinking, again, I can talk to Ackoff's thinking, because I knew him not only at Case for 3 years, but I joined the faculty of Wharton after he moved to Wharton, and I was appointed both in marketing and in management science. So I had a joint appointment. I had some dealings with Ackoff there as well. But the point you made earlier about the disciplines, I thought was very good. When I became a professor, an assistant professor of marketing at the Wharton School, I had never had a course in marketing. Okay, there was a great movement of it generated by a man named Roe Alderson, who was on the faculty of Wharton, who was a consultant, and he was bringing in all kinds of new people into marketing, many management scientists, psychologists. The change of thinking was very clear. Up to that point, marketing was thought of as a part of applied economics, the economics of distribution. Mm-hmm. And Roe said, wait a minute now, marketing is more than applied economics, it's applied psychology, it's applied sociology, It's applied mathematics, so that you don't have to just be an economist to really understand something about marketing. And he had a profound effect on changing the discipline of marketing in very fundamental ways to what it is today. And you look at the marketing curriculum in most universities today, it's highly mathematical, for example, a lot of mathematical models, which just didn't exist prior to that time.
Wonderful. Thank you, Arvind. It's wonderful to have you here. I look forward to continuing the conversation. Next up is going to be Anita, Jonathan, Judith, and Yen. Anita, go ahead. Anita, you need to unmute yourself. Okay, go ahead.
I was in the wrong place. Okay, so I want to address what you asked us to, which is this question about boundaries, or if we had anything else. So I think they fall in several categories about it. So I thought that's important to reiterate something you already did mention: systems change and evolve. So much so in the manner of, ecosystems. The paradigm of systems is ecosystems. And they then are invoking an understanding of that in this process of changing, evolving, you're changing interrelationships. You're changing perhaps the contingencies, whole avenues of causality. The entire word of complexity doesn't speak to it, so we could say complexities also evolve and change. So I think that there's something not sounding quite so, important to me about looking at boundaries, because I have no idea if I just take this point of, this, if I take it as a fact that systems are complex and they evolve and change in this way that includes their interrelationships, includes all these contingencies, causalities, and complexities. What's the point of trying to find some boundary as something so significant to guide me? I don't know where searching for these changing, evolving interrelationships might reach me. So for that reason, I put my hand up about looking so diligently for boundaries. And
Thank
for
you.
another reason,
that was a great question. Great. Thank you very much. So we'll put that in. So that's a very interesting, that's a very good question. And we will go ahead and deal with it. It's a beautiful question, because I think boundaries are critical to be able to deal with the complexities, but we'll get into that discussion soon. Okay. I want to give everybody a chance to put their basic thoughts on the table at this point, and then we will discuss all of this. Thank you. Next up is John, Judith, Yen, David Roller, and David Somerville. John, go ahead.
Yeah. One of the things that occurred to me about the video and the two stories that he shared, one with the students in the hard, inner city school, they learn to read, and the other one about the elevator. The elevator was that, and the mirrors was that. In both cases, it involved sort of, let's say the system in one case is a school, and the other system in one case is sort of a building and its tenants. In both cases, it involved sort of stop trying to fix one subsystem and sort of changing something in another. And I thought there was something pretty interesting about that, and that sort of the system that would sort of be most obvious, right? You think make an elevator, make more people go in an elevator, like, they tried all these things and they're fiddling with it. And then all of a sudden some crazy idea comes and they sort of, and I wonder how much of that is a general principle that can be applied. Like, for instance, I'm wondering what would happen if they had tried to fiddle with both systems at the same time? Would it just become too indeterminate? I mean, maybe it would work, but like, how would you determine what was working or not? Like the students in the inner school, like if they had done the Charlie Chaplin thing, but also like, flipped around the entire curriculum, like you wouldn't be able to learn it. So I'm just wondering like that sort of dynamic, is it more advisable to change one system at a subsystem at a time to avoid ambiguities and taking away false positives.
Yeah, that's basically Mill's method. So that's absolutely great question of how do you kind of systematically vary things in order to figure out where exactly the causality lies. And I think John Stuart Mill has done some really good work on that. So we'll come to that. Thank you, John. Next up is Judith. Judith, go ahead.
Yeah, okay. So I don't have a question. I'm possibly coming from this at a different angle, but I have a few comments to make, different
Sure,
comments.
as long as you're brief, go ahead.
I will try to be brief. Okay.
Yeah.
So first thing is I watched half the video. I found it really interesting. I want to finish it. My daughter teaches in the Bronx in a very regimented charter school. She has crazy stories that show that kids are really, really smart when they want to apply themselves, when they're motivated. And often that motivation comes into in being, in their behavior problems, but that's where they show, that they're motivated to do something naughty. They can figure out how to do it, and quite complex, including writing accurately like teachers. In my own office structure, I see, and I work in a small office, and I just see that systems thinking is really important there, because all the different departments, all very small, it's a medical office, billing, doctors, all the communication, things are always changing. It's extremely hectic, but without systems thinking, when the different specialties work separate from each other, it's not really well coordinated. So I feel there's inefficiencies there. And then just a small personal story. I've been struggling the last 2 weeks with a product that I ordered from Walmart online that I can't return to the store, and that and I have to deal with a warehouse. And then another part of the organization who I communicate with and has to follow other rules and can't get a refund. And just the whole system is not working in a cohesive way, and they're working separate from each other. And it's another example where businesses need to think in systems ways, I think. And I also believe it starts with education, which is why I enjoyed that he had so many stories about education, because I feel that that's where it starts, the thinking, the freedom to do things creatively, and nurturing that with children, more the way that we did maybe 20, 30 years ago than happens even now. So how to do that and still keep kids learning,
Absolutely.
I don't know.
We'll be dealing with that in the second section on learning.
Okay.
Looking
All
forward.
right, thank you.
Great observations. Thank you. Next up is Yen.
Okay, hi. I wanted to address Ryan's question about boundaries, but I'll start from the high-level systems and work down to basically functions. And his example, or one of the examples given about Amazon, say the function to be able to deliver an order by one day, and try and control that process to be able to meet the intent. I worked in the military, and the military also was trying to do the same thing, not what Amazon's trying to do, but trying to get the system to perform as intended. And that's kind of one, you can look at that as one of the effectiveness measures, the commander's intent, to deliver what the commander intended to do, not some other things, like doing the wrong things, okay? So the government is a system, the Air Force is a system, and a subsystem I've worked in was Air Force in the District of Washington after 9/11. And one of my jobs was to define all the subsystems as well as processes, and you just work down from there, because there's a master plan that the government has anyway. And you map all the processes on downwards up to a point where it affects the individual, and automatically, and the intent is basically in the long term, which government has, view of being able to automate the things that a machine can do well with less defects. Whereas humans require judgment, which is more art, you still leave to the humans to do. But in either case, you break the pieces down, going top down, as I was saying then. In the Amazon example, then, is that one of the intent of Amazon is to deliver your package in one day, overnight. prime anyway. So from Ryan's point of view, is then your subset responsibility in that function is to control that function through continuous improvement. And in doing so, you will also then perfect the whole system continuously to perform as intended from bottom up. Okay, so practically at the individual level, you set the boundaries in the areas that you're working with, and you measure that area to get reality. How is that system or processes performing to capacity at this time? And you continue to iterate and modify and improve the system, those functions and processes in order to achieve the ultimate end, which is what the commander intended all the way on top.
Thank you, Ian. Very nice, thank you. Next up is David Roller, David Somerville, and Kevin. David Roller, go ahead.
Hi. So I found the video actually to be very insightful. And as I was watching it, I could reflect back onto some of my own experiences and not actually understanding that I was actually implementing the systems theories as I was practicing. One of the, I guess you could say, the way I used to describe what I did as I led projects was I use a technique which I referred to as rapid prototyping. Is instead of trying to digest the problem and come up with very detailed design specifications and documents, is I pushed forward with basically trying to build the system, or trying to at least investigate the system conceptually through prototypes. So as you had ideas, as the team put ideas together, you would move forward those ideas, validating the ones that had merit, also finding out where you had weaknesses, and then keep going through a very iterative process. And you, over time, and some of these projects actually took 1 to 2, 3 years, you could see how the level of detail and the maturity of the design became, would manifest itself as you went forward. But by using this, what I, as I said, a prototyping concept, is you would push forward and past areas where you didn't have enough detail. And so one of the problems I would always have with engineers was they needed the detailed specifications and were very reluctant to move forward. And I said, well, let's just put a placeholder there. We'll make an assumption that this thing will do this and will give us this kind of a result. And let's keep building the whole. And by doing that, it allowed the overall program to move forward. And then the pieces would get filled in from behind. And then the total then could come together, and you go through that overview, that iteration again. And that I found to be very beneficial, especially when you were dealing in extreme multidisciplinary programs.
Thank
where
you.
You had electrical and mechanical and materials and thermal, and you have a lot of disciplines coming together. And some disciplines could move faster than others in being able to resolve and address, the requirements or the issues and get towards a solution.
Thank you. Thank you, David. What we will do is, this is a fantastic point. We did a whole meetup on the kind of agile or evolutionary style of design, which Tom Gilp talked about, last Sunday. So folks, I would recommend that you go to 52 Living Ideas YouTube channel and, and talk about that. This is a crucial idea of this kind of feedback loop, kind of relentless feedback loop, which keeps designing something that is working and delivering value and keep on expanding, and you keep on doing these loops and kind of build things out that way. So it's very effective. Thank you, David. Next up is David Somersville, Kevin, and Jyoti. And then we are going to go to the breakout rooms. David Somersville, go ahead.
Okay. Yeah, hi guys. It's nice meeting you got going on. So I had a couple of thoughts about the boundaries. One was I thought it might be driven by purpose. Why are you defining a system? And they'll give you a lot of knowledge about where the boundaries should be. And then the other thought was coming from complex systems, that, systems are usually made up of parts and relationships, and that sort of speaks to the idea of an automobile. It's not just the parts, it's the way those parts relate to each other makes up the system. So maybe that's part of the boundary thought as well, is that a system is made up of all the parts and the relationships, and you still have to prove out that you've got a good system there. So you may find that there's relationships that then go outside what you initially thought was the system for whatever purpose you're defining it. So in the example of the automobile, you may start thinking about petrol or gasoline. Where's that coming from? Maybe it wasn't part of your original system definition. And that may tie into the thoughts on education. It didn't look like he went outside some system that he'd defined originally about what the school is as a system. He wasn't thinking about what he needs to do out in society, or at least didn't seem to. So he had some boundary put in place even for that problem. And it may be pragmatic what he wants to define as the boundary, is what he can have control of.
Excellent. Thank you. Thank you, David. Next up is Kevin, followed by Jyoti. Kevin, go ahead.
Yes, my idea is system solve. Like, guess system thinking is the design stage. We need to clarify what the system solve. Let's say, for example, use a car solve. We need engine for sure. Let's see, for engine solve, we need what kind of cylinder, 12, right? Then from engine, then after engine, you need transmission, how it interconnect together. That's between those components. You need two components. You need design how to look like. Also, out of box thinking, you need to consider the time and the cost, right? Let's see what we're going to achieve. Let's say, I guess, just got the answer purpose of what are we going to achieve for this design system thinking. So it's
thank you.
Yeah.
Right. Welcome back, folks. All right. So we'll go to the next part now. So the next theme is about learning. Okay. I want to start off with children. Okay. Ackoff has a beautiful observation. One of the thinkers I've learned a lot from, Jacob Bronowski, has a great observation. Buckminster Fuller has his own observation about this. Ackoff talks about the study that Edward de Bono did on children, and notices that there is tremendous creativity in children. You look at children, look at how curious they are, how relentlessly they pursue trying to know. And he found it widespread in children. Every child in their own way is creative, is insatiably curious. Jacob Bronowski puts it on a much more kind of biological way. When he looks at human beings in the context of all living beings, he notices, Jacob Bronowski produced this series called Ascent of Man, which was one of the first documentaries ever produced, 13-part series. I recommend it very highly. The final episode is called The Long Childhood. He notices that the thing that distinguishes human beings is that we have long childhood. As the brain size keeps increasing, the length of childhood, even proportional to our lifespan, keeps increasing. So half our brain, we are born with only half our brain fully developed. Rest of the half develops in interaction with reality, by doing things, dealing with interacting with other people. So his core observation after that, he says, in the old world, in the primitive cultures, they hold the adult as the goal. He shows these statues from Easter Island. And what they are saying to children is that you grow up to be like that. It's a fixed ideal. It's a fixed ceiling towards which you grow. So you learn in order to reach that, and then that's the end. That's what life is about. Whereas Jacob Branowski talks about the West as having the child as the ideal. Anybody who can maintain that childlike curiosity throughout their life, that is a man. So people like Leonardo da Vinci, you find that, or many, many, many great thinkers that I've seen, I find that their curiosity, their desire to know, their openness to learning new things actually kept growing over time. So in that sense, there were more of children as they went on. Ackoff talks about de Bono's studies, and he says he finds that creativity is universal in children, but then he looks at adults and finds what happened, what went wrong. We should be better. We should grow. We should grow in our ability, but exactly opposite happens. What goes wrong? What goes wrong? It's a very simple, fundamental question. And his essential answer is conformity. There are many, many ways of answering that. My favorite thinker on this is Louis Sullivan. So I will answer it in his words. He says, function, so the child has the function, and the form is malleable. At some point, you achieve some form which is serving you to some extent, whether at a cultural level, whether at an individual level, and then you replace the form, which is not a living thing, in the place of where the function needs to be. And from then on, you are no longer living, you're using the fixed structure. So it is all about conformity. It is saying that, oh, everybody has figured out how to do this. This is how you do it. So you just do that. You do not ask the question of what is it? Why are we doing this? Is that the best way of doing that? You're not actually seeing things. You are using, and see, we have got amazing brains. We've got very large brains. So our capacity of developing habits and doing habits with very little energy is fantastic. It's a great thing to have this large brain capable of doing these automatized motion. But if you replace, and it is powerful in its own context, but when you use that function to replace actually looking at reality, actually engaging with reality, and actually trying to solve problems, it is destructive to your creativity and what it does. Now, Ackoff talks about teaching, and I think that was amazing, amazing thing, because again, it comes down to this. We did 2 meetups, one with Robert and Michelle Ruth Bernstein, who have studied polymaths, and one with a mathematician. And both of them, in their own way, had the same complaint. The complaint was that scientists or mathematicians or people, or the way in which science is taught, or way in which mathematics is taught, what is being given is the results of the process of doing science, results of thinking mathematically, and not what it is to to do science, not what it is to measure things as a mathematician. So what is taught are products of a process, not the process itself. And the worst thing is that you think that you have something, but you have only the product. And you have the illusion that you have a process, that that's all it is all about. And that is very, very destructive. The other point, the point that Ackoff is making here is that all learning is self-driven. You have to learn how to learn. You have to be motivated to learn, and you have to learn it in your own way. You have to make the knowledge yours. If you don't do that, there is no, the model that you can passively absorb knowledge is false. It is through active process of experimentation, and I would throw in the action component to that, coming up with a hypothesis, testing it out, improving the hypothesis on a relentless basis by yourself is the way to learn. The best system, education system I've found along these lines is the Montessori system, which works beautifully from the age of 3 to 6. We've done a full meetup on Montessori. You can find it on 52 Living Ideas. But that, I mean, again, to kind of summarize the Montessori idea, is that Maria Montessori held that a child is an independent being. And what a teacher can do is to provide the right environment so that it is accessible to the child all the time. So the child explores that environment and learns by doing that. And what teacher is doing is that they are the guides. They are there watching, not imparting education, but they're watching. And if the child gets stuck on something, they will help a little bit, give a little bit of suggestion. But most of it is inner driven. And what happens, what I've found is that children who go through that come out as independent beings. They learn how to learn. They get hooked onto learning. They are motivated to learn. And what Ackoff is saying is that if you can get those two things, you have everything. Everything else then is up to them, and they will do it on their own. But I want to take a different tack on this, because it is easy to talk about children because they are not you. But that same point applies to you as much as children. Okay, in some ways, by complaining about just complaining about the education system, you are actually shifting the responsibility away from you. We all are children. We are all faced with reality, a lot of which we do not understand. And it would be wonderful if we understood a little bit more of it. So this process of learning is something that each of us has to do. And one of his key observations is that you learn by teaching. And that is what all these meetups mean to me. So for example, I'm learning about Ackoff, I'm learning about Buckminster Fuller, and I'm talking about it. I know that I know very little about Ackoff, but I'm trying to explicate what little I know. And in the process, firstly, I'm clarifying my own ideas, and I'm getting crucial feedback from people who know a lot more than me about this, like Arvind, like Tom Gilb, like Sanjay, we've been spending, we've spent a lot of time on that, like CJ. And that's a very fast way of learning. And one of the things that we are trying to do, CJ and I are trying to do with these comprehensive Wednesdays, is to make that available to everybody. Okay, so what I'm going to do is that next Wednesday, I'm going to invite you to learn by teaching. Okay, you're going to have 5 minutes. to talk about anything that you're learning. Please, you don't need to talk. You can come and listen, but you get about 10 times the value if you try to explicate your thought to others and get feedback from them. You will find that the questions that they ask many times are things that you have not thought of. This is an amazing group of people, by the way. We get amazing group of people from all over the US, all over the world to show up from their wide variety of experiences, their widely different perspectives. And we have a structure where we can, I call it my meetup, the theme is joint exploration of the world. Joint exploration of world and ourselves and ideas, if you want to put it. It's a fast way of learning. But it means that you put curiosity above, pretending to yourself that you're right or pretending to others that you're right. You actually want to know what is true. And if that's what you want, then I think this is a wonderful forum. And I think the more you participate in it, more actively you participate in it, the more you will get from it. Okay, so that's what I want to do. Now, what I want to do now is I want to now do breakout rooms right away. And I will go to each breakout rooms and by turn. So what we're discussing in the breakout room is these ideas about learning. Focus on your own learning, lifelong learning, and say, okay, how do you do it? What are your strategies for doing that? What did you learn from Ackoff about how you can learn? Okay. And then I'm going to ask you whether you would be willing to talk about, something that you're learning for just 5 minutes. Okay, it's very informal. We've done this before. It works beautifully. Okay, so it's going to be an amazing meetup next Wednesday. And I'm going to come to each of the room by turn and ask, what you would like to talk about. And then I will go and then you can continue your discussion. All right, so I'm going to start the breakout rooms momentarily. Welcome back, folks. All right, people are still coming back. All right. Welcome back. So now it's time for takeaways. What I will do this time, it's a little late. So anybody who wants to talk about takeaways can go ahead and type exclamation mark in chat. We would like to know what you're walking away with. I'm going to start calling on people. If you want to share your takeaways, type exclamation mark. I'll come to you first. I'm going to ask people in order. If you don't want to share your takeaways, you can go ahead and type skip. Okay, maximum 1 minute. I want to go through everything very quickly. So question is, what are you walking away from? What did you get from this meetup? What are you walking away with? So I will start with Erwin, David, and Tom. Erwin, go ahead. You need to unmute yourself.
I came away with it's lovely talking to smart people.
Excellent. Beautiful. David Roller, Tom, and David Somersville.
This was actually a very interesting group. I found quite a diverse set of perspectives here, and I found it very enjoyable. One thing that I will mention, I didn't know you could do these breakout things in Zoom. So this was kind of an interesting thing to see how to divide the group up, get a little bit of conversation going without having the whole group needing to participate. So very enjoyable.
Thank you, David. By the way, if any of you are not already members of 52 Living Ideas, please go ahead and join, because we have meetups every day like this. And this is a normal meetup. This is not an unusual meetup. This is what happens. Both kind of the quality of content, quality of people, quality of discussion this is what we have every day. So please join, and we'll go from there. Next up is Tom, followed by David Somersville, followed by Gary. Tom, go ahead.
Okay, so the diversity of people, levels and interests is amazing. So that you managed to somehow get us coherently speaking to each other is amazing.
Thank you, thank you. This is what I've been doing in New York, which is the center of universe where people from all kinds of walks come up. In person, I had like between 30 to 80 people. So if I can do this with 80 people, 80 New Yorkers, very strongly opinionated New Yorkers, this is a piece of cake. This is very easy. Thank you, but appreciate the compliment. Next up is David Somersville, Gary, and Jeff.
Yep, again, first time here, so yeah, it's great to meet all the people. It's a nice mix. I guess my takeaway is I should have read the instructions better and actually watched the video before the call, but I faked my way through it, so I'm pretty happy. It's good.
I would recommend still watching the video. It's amazing. So and you can follow up. The great thing about it is that these discussions go on. Like some of these, we will be coming back to these ideas in breakout rooms, in the main meetups. So yeah, you can always catch up. Next up is Jeff, Judith, and Victor. Jeff, go ahead.
So during the breakout, I was actually reminded of one of my favorite lines from one of my best mentors, which is simply this: as an element of systemic thinking, whatever you start out to do with the best of intentions for someone, without getting their input and their feedback, you will most likely end up doing to them.
Excellent. Thank you. Thank you, Jeff. Great one. Next up is Judith, Victor, and Donna. Judith, go ahead.
Oops, yeah, I'm sorry. So my takeaway was the importance of listening in systems, the importance of listening to ideas from non-experts, and that the idea of diversity is important because to understand the system, you have to know all the different parts, and sometimes experts can have a narrow point of view. So
thank you. Thank you, Judith. Sorry, I skipped Gary by mistake. Gary, you're next.
Okay, my takeaway, first of all, like I said, this is a great group. Laura Shapiro, I think her name was, she was talking about education in our breakout room. Incredible conversation, because that's something that I've wrestled with. I just don't understand how we can help a lot of these marginalized students to get beyond where they are to a point where they can be self-sufficient. And my other takeaway was that you were talking about system thinking people. W. Edward Deming is also a guy, even though my professors thought he was kind of dated in college, but I still think a lot of what he did in system thinking is pretty good. Mm-hmm. And that's it. Thanks.
Excellent. Thank you, Gary. Nice to have you here. Next up is Victor, Donna, and John. Victor, go ahead.
Hello, guys. Yeah, I really enjoyed this meetup tonight. And yeah, I picked up a couple of things about systems thinking, especially subsystems, and how they are related to the actual thing that we are going to solve, either in mechanical world or in a social setting. So it's quite a rich topic, and I'm very excited for next few meetups where we discuss the idea in depth.
Absolutely. Thank you, Victor. Next up is Donna, John, and Brian. Donna, go ahead.
So my takeaway is that I am even more curious now about system thinking versus design thinking, how they work together, and then also strategic thinking. So how everything works together.
Excellent. Thank you, Donna. Next up is John, Brian, and Ayala. John, go ahead.
Yeah, I guess one of the things just from talking to people and getting people's ideas, and also from the lecture, is that in one subsystem, maybe a mountain, but in another in another subsystem, you may have to move a mountain in one subsystem, but in another subsystem, maybe you just need to pull a lever.
Mhm.
And before you go and start trying to dig through that mountain, you might want to see if there's a lever, because it probably will save you some time. So anyway, overall fascinating conversation. And
Thank you. Let's go to Ayala, followed by Brian, and then Jairo. Ayala, go ahead.
I have to say much more than 1 minute, so I'll skip.
Okay, sounds good. Next up is Brian, Jairo, and Mary.
Okay. Yeah, it was an enjoyable session. The mistake I made was that I didn't find time to listen to the video, which I shall now do in the morning. I am quite experienced with systems thinking, systems analysis. I worked a lot on it in the past, and I thought I would know enough, but it proved to me I still have a lot to learn.
Excellent. Thank you, Brian. Next up is Jairo, Akavi, and Linda.
I heard something that David Roller said about rapid prototyping, and I'd like to learn more. And then I heard, or before that, I heard something that Joseph Bullock said, maybe, or someone else said about figuring out the boundary of a system. And I was thinking of what about, are there something that you want to systematize that doesn't have a boundary, like it's boundless? I was thinking of the mind as being boundless.
Okay, thank you.
Thank you.
Thank you, Jairo. Next up is Kavi, Linda, and Jyoti. Kavi, go ahead. You have to unmute yourself. Nope. Okay. Next up is Linda.
I enjoy learning, and I find a wealth of knowledge with this group. Whatever the topic is, I enjoy hearing about it.
Thank you. Thank you. Next up is Jyoti, Anita, and Yen.
I always find these discussion groups very fascinating, and you did a good job in simplifying Ackoff's principles, disciplines, and what have you. But the most I liked is my breakup group, the first and the second. The first breakup group had no difficulty understanding my question. So Sanjay and Joe were very nice about explaining and taking off from there. And we went into the depth of my question. So I came out very satisfied. And the second breakup group was also very impressive. We talked a lot about each other's passions and hobbies and our occupations. And I learned something from each one of them. So I'm glad that I was here today. Thank you.
Wonderful. And for those people whom I was not able to talk to personally, like Donna, Judith, Kim, Linda, Gary, Victor, and Joe, you're invited to come back next Wednesday, and really look forward to hearing you talk about whatever it is that you're learning. And as I was telling other people, you will find that for most people, learning is too passive. When you start to actually trying to do something with it, like talking about it, you end up getting a level of clarity. You are forced to organize the structure of the field, and you get the experience of talking to somebody else and getting their feedback. Also, this is a community. The more you tell people about what you're interested in, the more you're going to get out of the community. More people are going to be able to see what you're capable of, and they're going to want to talk to you more. So please take the opportunity of talking to people. If you can't talk for 5 minutes, you can talk for 1 minute, but 5 is tops, because I want to make sure that we get to everybody. All right, next up is Anita, Joe, and Dave. Anita, go ahead.
New for me was encountering this intriguing impulse by a number of people about looking at and finding and discovering and discussing boundaries never had come up as a topic of concern. You did promise we'd get to it later. We really, I don't think, did touch on it, but nevertheless,
No, no,
it's
no,
now
no,
on my
no.
horizon.
No, Anita, when I say later, we talk every day. We talk every day. There are meetups every day. And the thing
Okay,
is that
understood.
some of the problems are slightly larger that can't be fully handled, that not all questions are answered. And the way I see it is that formulating the question is the most important thing. So for example, the question that you have formulated is very beautiful. The question is, how is it that when there are things, phenomena which is extremely complex, how do boundaries actually work in that? Like for example, brain, right? Brain is so complex, the interaction, but understanding boundaries of a neuron and seeing exactly what a neuron does at a cellular level is key to understanding the whole. So something like that. So it's of being able to kind of see. So there are all kinds of interesting things. This theme of systems we are going to pursue over a period of time. So so absolutely. And what happens is that we can't, what happens is that there are lots of kind of questions that come up like this, and we follow only some of them. And the structure of breakout rooms exist so that people can pick up the questions that really interest them and run with them. So that it's all designed for that. All right. But okay. But thank you very much, Anita. I really appreciate your question. It was a fantastic question. Next up is Joe, Dave, and Mcgill.
Yeah, so one of the things that I'm taking away from is the idea of boundaries, and it's simplistic, but the idea of purpose and how that relates to your boundaries and how you determine right or wrong within that. The second one was the question, the point brought up by Yen, was how and I need to keep thinking about this, is how does continued process improvement that he had mentioned, work with systems thinking? Because one of the things that I had thought about is you always have to question whether the process itself has to exist. And so that's something I need to think about, how systems thinking and continued process improvement work together. And there's also economic principles that I had not thought about for a long time, specifically creative destruction, how that fits into systems thinking as well. That's a really interesting thing that I haven't read about for a while, and I'm going to take that away from here and really think about when does it make sense to reinvent the system. And I think that also will set boundaries as well.
Excellent. Thank you, Joe. Next up is Dave, Mcgill, and Evanik. Dave, go ahead.
Yeah, thanks, Shrikant. Another very interesting discussion this evening. Very interesting gentlemen. As I apologize, I got my schedule today screwed up, and so I've got to go back and watch the final 30 minutes. But what I saw was just fascinating, and I look forward to future similar discussions about some of these great men and this type of thinking. Thank you.
Thank you. Thank you, Dave. Mcgill, next up is Mcgill, Evanik, and Kevin.
Well, I'd like to thank you for sharing the knowledge of Ackoff and all that he has to contribute. I started reading the book, Redesigning Society by Ackoff, in addition to watching the videos and all that. It's really captivating. I keep on going back to the boundary thing. When we were in one of the breakout rooms, I remembered the movie The Power of 10 by Charles Ames.
Mm-hmm.
That if you're in a bind trying to find focus, just take one step back and keep on stepping back, making the system bigger as you come across barriers. So you can always focus out or focus in depending on what you're trying to solve. And to Joe on the continuous improvement, Deming, and have the continuous improvement process, which you try to solve the problem, and then you take the steps, the actions, and then it's a feedback loop. So every time you try to solve it, and if it you can always affect for the next round. So you keep on trying. It's an iterative process. There's
Thank
no
you.
right or wrong. You can stop doing it or not.
Excellent. Thank you. Excellent point, Mcgill. Next up is Evanik, Kevin, and Anne. Evanik, go ahead.
So yeah, so what I took away from this is there are many different ways of learning and what lights people up. And the experience of learning is when somebody finds something that interests them. And as far as systems, what I found is that, based on the video and discussions in the breakout groups, is that you have to really know what problem you're trying to solve. And one person in the breakout group said it best when he said, when you're trying to solve a problem for something or someone, and I'm summarizing here, sorry, it doesn't really work. You wind up like doing something to someone, but rather than something for someone. So that's it.
Thank you, Evanik. Next up is Kevin, Anne. Kevin and Anne. Kevin, go ahead.
Let me put my takeaway as logical. Let's see. I would say this: if you cannot change the world, you try change yourself, or you change your mind, change the system, how you think.
Okay, thank you, Kevin. Next up is Sanjay, Kim, and Marian. Sanjay, go ahead.
Yes, so tonight was wonderful. I enjoyed both of the breakout rooms. Also, I enjoyed the presentation of systems theory that you and others discussed, but especially the questions that people asked. I found that it helped me to understand the areas of system theory that is difficult. I mean, I've been practicing it for so long that to me it's, I don't want to say obvious, but and there's still areas that are difficult for me, but it's enjoyable to hear the questions that people posed, primarily because I think that questions are the most powerful way for us to learn something difficult. Especially if we ask questions and have them answered by people who bring clarity. So thank you.
Thanks. Next up is Kim, followed by Marian. Kim?
Yes, hi. This is my first meetup with this group. It was a peek in the window. I like what I see inside. And I found the YouTube video. I only watched half, but it was fascinating, relevant to my work life, and I think to other aspects of, life. And it's a lot for me to unpack, and I look forward to visiting with this group in the future.
Absolutely. And for those who are new, we have done more than 250 meetups during this COVID times, and more than about 200 videos are up on our YouTube channel. So go to YouTube and type 52 Living Ideas. You will find a number of videos, including 2 videos on systems, multiple videos on Bucky, many videos about this comprehensivist approach of kind of transdisciplinary approach. We have an entire, I think about 20 different videos on just that. How do you kind of think across disciplines? So that's what is coming. Marian, did you have any comments?
Yes, thank you so much. This was my first time to also today, and I enjoyed the meeting. My takeout was I'm doing a lot of learning this time, and I'm really interested in adults learning. And what I take out today is that I have to go back to my childhood curiosity if I want to make my learning easier. I think that's what I'm going to do. Thank you.
Wonderful. So on that great note, good evening, everybody, and we will see you next time. Bye.
Thank you. Bye.
Thank you. Bye.
All right,
Bye.
thank you.
Thank you.
Bye.